right, so get this. We got sent this essay, and it's by Jurgo Schneeppert.
Okay.
And it's all about this physicist, Carl Wieman.
Mm-hmm.
And he won a Nobel Prize for his work
Wow.
on something called Bose-Einstein condensates.
Okay. BECs.
BECs, all right.
Have you ever heard of these?
You know, it's funny because most people haven't.
Yeah.
But they're so cool. Even if you don't know that much about physics,
Yeah.
Schneeppert really lays out Wyman's journey like it's a scientific superhero story.
It really is. Like, he starts as just this kid in Oregon.
Right.
Fascinated by, you know, the world and everything around him.
Yeah.
Ends up making these groundbreaking discoveries.
Exactly.
Exactly.
And what I think is so interesting is that he wasn't just like born a genius.
Yeah.
Schneeppert really highlights how he cultivated this intense curiosity and love for experimentation from a young age.
Yeah.
Which really set the stage for all of his success later.
Okay, so let's talk about these BECs for a second.
Okay.
I gotta be honest, the name alone.
This makes my brain hurt a little bit.
Sure.
Schneeppert mentions that they're a strange state of matter, but what does that even mean?
Okay, well, imagine a stadium full of people.
Yeah.
Each one representing an atom.
Gotcha.
Now picture all of them suddenly moving in perfect unison like a giant wave.
Whoa.
That's kind of what's happening in a BEC.
Really?
But at the atomic level.
So you're telling me that atoms are acting like one giant entity?
Pretty much.
Wow.
They're cooled down to almost absolute zero.
Okay.
Which is unbelievably cold.
Yeah.
And that causes them to lose their individual identities and behave as a single quantum wave.
That's wild. So Wieman just stumbled upon this.
He didn't just stumble upon it.
Okay.
Schneeppert points out that the theory behind BECs was actually proposed way back in the 1920s.
Oh, wow.
By Satyendra Nath Bose and Albert Einstein.
Oh, so it was already...
But back then, the technology to create a BEC just didn't exist.
So it was a waiting game.
Exactly.
For science to catch up.
Yeah.
With the theory.
It took decades for scientists to develop these techniques like laser cooling and magnetic trapping.
Right.
Which are essential for creating those super cold temperatures needed for BECs.
Okay, I'm getting a sense of how groundbreaking this all was.
Yeah.
But I'm curious, how did they actually use lasers and magnets to cool down atoms?
Yeah.
I mean, I can heat up my leftovers in the microwave.
Right?
But chilling atoms with lasers sounds like magic.
It is pretty mind-blowing.
Yeah.
Think of it this way.
Okay.
Lasers can be used to slow down atoms by bombarding them with photons.
Okay.
It's kind of like using a stream of ping pong balls to slow down a bowling ball.
Okay.
And the magnetic fields act as a trap.
Right.
Keeping those super slow, super cold atoms confined in a space.
So they're basically wrangling atoms with light and magnets.
Basic.
That's incredible. And that's what Wieman and his colleague Eric Cornell did in 1995.
Yes.
Right.
They were the first to create a BEC.
At their lab.
In their lab at the University of Colorado Boulder.
Wow.
It was a huge accomplishment.
Yeah.
And it earned them the Nobel Prize in Physics in 2001.
That makes sense. But now I'm wondering, why should someone who isn't a physicist care about this at all?
Yeah.
Is it just a cool science experiment, or are there real-world applications?
That's where things get really interesting.
Okay.
BECs aren't just a scientific curiosity.
Right.
They have the potential to revolutionize technology in ways we're only just beginning to understand.
Okay, now you've got me hooked.
Yeah.
What kind of technology are we talking about here?
Well, think about it. BECs are incredibly sensitive.
Okay.
Schneeppert talks about how they can be used to build super precise sensors. Like the kind used in navigation systems.
Right.
Or even for detecting gravitational waves.
But hold on, gravitational waves,
Yeah.
those ripples in space-time that Einstein predicted?
BECs could be the key to building detectors sensitive enough to pick up these incredibly faint signals from the universe.
So BEs could help us unlock some of the biggest mysteries of the cosmos.
Absolutely, and that's just one application.
Okay.
Schneeppert also talks about how BECs are paving the way for quantum computers.
Quantum computers, those things that are supposed to be like 1,000,000 times faster than regular computers.
More than 1,000,000 times faster.
Right.
They have the potential to revolutionize fields like medicine materials, science, and artificial intelligence.
Wow.
We're talking about solving problems that are impossible for even the most powerful computers today.
So Wieman's work is essentially opening the door to a whole new era of technology.
That's a great way to put it.
Yeah.
But what I think is really fascinating is that Schneppat highlights how Wieman isn't just focused on the science itself.
Right.
He's also incredibly passionate about science education.
Oh, right. I remember reading about that he believes that everyone should have access to scientific knowledge.
Exactly. And he's not just talking about it, he's actually doing something about it. Wieman has developed innovative teaching methods that focus on active learning and hands-on experimentation.
Oh, cool.
He wants students to experience the joy of discovery firsthand.
That's awesome.
Not just memorize facts from a textbook.
Yeah, like actually do it themselves.
Exactly.
That's so cool. It's like he's trying to create a whole new generation of curious minds.
Right.
Who are excited about science.
And you know what's interesting?
What's that?
Schneppat points out that this approach to education actually mirrors Wieman's own research philosophy.
Real.
He believes that the best way to learn and make breakthroughs is through collaboration and open communication.
So it's not about working in isolation.
Not at all. Wieman is a firm believer in interdisciplinary collaboration.
Okay.
He's brought together physicists, engineers, computer scientists, all sorts of experts to work together on these complex challenges.
Wow.
He recognizes that the biggest breakthroughs often come from unexpected connections and diverse perspectives.
That makes so much sense, and it's probably why he's been such a successful mentor to so many young scientists.
Absolutely. Schneppat really emphasizes how Wieman has fostered a culture of collaboration and mentorship.
Yeah.
Both within his own research groups and in the broader scientific community.
Really cool.
He encourages his students and colleagues to challenge assumptions, ask tough questions, and push the boundaries of what's possible.
So it's not just about passing down knowledge. It's about inspiring a whole new generation of scientists.
Yes.
To think differently and approach problems in new ways.
Precisely. And that brings us to another crucial aspect of Wieman's work.
Okay.
His dedication to science communication.
Right.
Schneppat talks about how Wieman believes that scientific knowledge shouldn't be confined to academic journals.
Yeah.
Or university lecture halls. It needs to be shared with the world.
He's like a science evangelist.
Exactly. He's given countless public lectures, written articles for popular magazines, and even appeared in documentaries.
Wow.
He wants to make science accessible and engaging for everyone, regardless of their background.
That's so important, especially in a field like quantum physics.
Right.
Which can seem really intimidating to people who aren't scientists.
I know. I remember when I first started learning about quantum mechanics.
Yeah.
I felt like I was in over my head. But Wieman has this incredible ability to break down complex concepts and explain them in a way that makes sense.
Right.
Even to someone like me who doesn't have a PhD in physics.
So he's not just making groundbreaking discoveries, he's also making those discoveries understandable.
Yes.
And relatable to the rest of us.
Oh,
that's pretty awesome.
It is, and it's a testament to his belief that science is a powerful tool for understanding the world around us.
Yeah.
And that understanding shouldn't be limited to a select few.
It sounds like Carl Wieman is not just a brilliant scientist, but also a visionary leader and a passionate advocate for the power of science to make a difference in the world.
Absolutely. And Schneppat's essay really captures that multifaceted aspect of his personality and his legacy.
It's been a fascinating journey so far.
It has.
But before we wrap up our deep dive into the world of Carl Wieman, I'm curious about one thing.
Okay.
Schneppat mentions that Wieman is acutely aware of the potential ethical and societal implications of these powerful quantum technologies.
Right.
What does he have to say about that?
Yeah, it's true. We often get so caught up in like the excitement of new technologies that we forget to think about,
the big picture.
Yeah, the bigger picture. Exactly.
Yeah.
What kind of ethical concerns is he raising?
Well, Schneppat points out that one of Wieman's biggest concerns is the potential for misuse of these technologies. Like, for example, quantum computers.
Okay.
Could be used to break encryption codes that protect sensitive data, or even to develop autonomous weapons systems that could operate without human oversight.
That's a bit unsettling, to say the least.
Yeah.
So what does he suggest we do about it?
Well, Schneppat explains that Wieman is a strong advocate for responsible innovation.
He believes that scientists have a moral obligation to consider the potential consequences of their work.
Right.
And to engage in an open dialogue with policymakers and the public about the ethical implications of these technologies.
So it's not just about making scientific advancements. No. It's about making sure that those advancements are used for good.
Exactly.
And don't end up causing more harm than benefit.
That's it.
Yeah.
Wieman argues that we need to start thinking about these ethical issues now,
right,
while these technologies are still in their early stages of development.
Yeah.
Because it's much easier to course correct early on
Right.
than to try to fix things after the fact.
I guess it's kind of like building a house.
Yeah.
You want to make sure the foundation is solid before you start adding all the floors and the fancy features and stuff.
And Wieman believes that education is a crucial part of this process.
Okay.
He wants to ensure that the next generation of scientists are equipped not only with the technical skills to develop these technologies, but also the ethical awareness to use them responsibly.
It sounds like he's really taking a long-term view here.
He is.
Not just focusing on the immediate breakthroughs,
right,
but the lasting impact of these technologies on society as a whole.
That's one of the things I find most inspiring about him. He's not just a brilliant scientist, but he's a deep thinker who's grappling with some of the biggest questions facing humanity.
Okay, so we've covered a lot of ground in this deep dive into Carl Wieman's world.
We have.
From his pioneering work on BECs to his passion for education and his commitment to responsible innovation.
Yes.
It's clear that he's had a profound impact, not just on the field of physics, but on the way we think about science and its role in society.
I agree, and I think Schneppet's essay does a wonderful job of capturing that multifaceted legacy.
Absolutely. What stands out to you from our conversation?
You know, I think what strikes me the most is Wieman's just unwavering belief in the power of science to make the world a better place. But it's not just a blind faith in technology. It's a thoughtful, nuanced approach that acknowledges the potential pitfalls and emphasizes the need for ethical guidance and open communication.
Well said, and I think that's a message worth remembering as we enter this new era of quantum technology.
Absolutely.
As Schneppet reminds us, it's up to all of us to ensure that these powerful tools are used wisely and for the benefit of humanity.
I completely agree.
And on that note, we encourage you to check out Jurgo Schneppet's essay yourself.
Yes.
And delve deeper into this fascinating world of Carl Wieman and the wonders of BECs. Who knows, maybe this deep dive will inspire you to explore the incredible possibilities of quantum technology and maybe even play a role in shaping its future.